Hey, what's going on guys? In this video we are going to see an example of integrator circuit. In particular we are going to see summing integrator circuit. Here we have a summing integrator circuit with 2 voltage input, and also we have the capacitor. We are going to find out this V output voltage. Okay, to find the V output voltage for a summing integrator, we use this equation. V output, that's equivalent to 1 over, we have 2 resistance, so 1 over R1C first, and then integration Vi1 dt, and then minus, also I had to put a minus right here, minus, and again minus 1 over R2C integration Vi2 dt. Okay, now let's go ahead and plug the values. Negative 1 over R1 is equal to 500 kilo ohm, so 500,000 ohm times the capacitance, that is 5 microfarad. Micro is 10 to the power of minus 6, so 5 times 10 to the power of minus 6 times integration Vi1. I1 is equal to 20 cos 2t millivoltage. Milli is 10 to the power of minus 3. Okay, 10 to the power of minus 3. Let's keep this one as millivoltage because finally we can express our answer in millivoltage. So let's keep this one in millivoltage, and that's it for the first part. So dt minus 1 over R2, that's gonna be 200,000 multiplied by capacitance, that's 5 times 10 to the power of minus 6 farad. Integration, the second voltage input is 1t dt. Okay, now let's go ahead and do the integration. This is going to be negative 1 over 25 times, like we are going to have 2,500,000 times 10 to the power of minus 6. So we are going to have 2.5 when we multiply, right? Because we have 10 to the power of minus 6 with this one, 2.5. And also we have 20 right here. What I'm going to do is I'm going to move 10 to this side, 10, and we are going to have 2.5 and cos 2t. To integrate this one easily, we can keep this one with 2 dt. Okay, 2 dt. 20, I separate this one into 10 and 2. In that way it's easy to integrate, and the limits of integration is going to be 0 to t. Okay, let's put the limits of integration 0 to t. 0 to t. Okay, so this is this one, and minus 2 times 5 is 10, and this is going to be 1 million times 10 to the power of minus 6. So all the zeros are going to cancel. We are left with 1. And if we integrate t, that's going to give us just t square divided by 2. And the limits of integration is 0 to t, 0 to t. So we have to subtract 0. It doesn't change anything, so we can keep this one like this, or we can just put one more step, 0 to t, since we are going to do this one. This is 10 over 2.5, that's equal to 4, so this is going to be negative 4, and if we integrate this one, that's going to give us sine 2t, sine 2t, and then that limits of integration is 0 to t minus t square divided by 2, and that's going from 0 to t, and sine 2t is going to be just sine 2t. If you plug t for t, that's going to be just 2t. Sine 0 is 0, so the final expression is going to be negative 4 sine 2t minus half t square millivoltage, and that's going to be the voltage output. And that's how we do this kind of problems. I hope this helps. Thanks for watching.